Hello everyone, welcome back to my YouTube channel. Myself Vidyashree MS, currently studying in Sri Venkateshwara College of Engineering, Bangalore. First semester, subject Mathematics, subject code BMATE101, topic Markov Analysis. Introduction to Markov Analysis. In this video, I am going to talk about introduction, types of Markov chains, advantages, disadvantages, and problems. Understanding the basics of Markov analysis. What is Markov analysis? How does Markov analysis work? What is periodicity in Markov analysis? How can periodicity be analyzed in Markov analysis? What are some best practices for using Markov analysis? Let us see the definition of Markov analysis. Markov analysis is a technique dealing with probabilities of future occurrences with currently known probabilities. Numerous applications in business, example, market share analysis, machine breakdown prediction, university enrollment prediction. History of Markov analysis. Markov analysis is often used for predicting behaviors and decisions within large group of people. It was named after Russian mathematician Andrei Andreevich Markov, who pioneered the study of statistic processes, which are processes that involve the operation of chance. Markov first applied this method to predict the movements of gas particles trapped in a container. Applications of Markov chains in various fields: finance and economics, biology, natural language processing, computer science, weather forecasting, sports analytics. Markov chains have many applications ranging from modeling communication networks to analyzing stock prices. They are particularly useful in modeling systems that have a finite number of states and transition between those states, and can be used to analyze and predict the long-term behavior of such systems. Types of Markov chains: finite Markov analysis, infinite Markov analysis, continuous Markov analysis, discrete time Markov analysis. Let us see the definition of finite Markov analysis. A finite Markov process is a random process on a graph where from each state you specify the probability of selecting each available transition to new state. Finite Markov processes are used to model a variety of decision processes in areas such as games, weather, manufacturing, business, and biology. Infinite Markov analysis. Infinite state Markov analysis are common in modeling systems where the number of customers or number of jobs is unbounded, and thus the state space is unbounded. The typical example is a queue of jobs or packets where the queue can grow arbitrarily long. Continuous Markov analysis. A continuous time Markov chain is a stochastic process that moves from state to state in accordance with a discrete time Markov chain, but is such that the amount of time is spent in each state before proceeding to next state is exponentially distributed. Discrete time Markov analysis. A discrete time Markov chain is a sequence of random variables known as a stochastic process in which the value of the next variable depends only on the value of the current variable and not any variables in the past. Advantages of Markov analysis. Markov models are relatively easy to derive from successional data. Does not require deep insight into the mechanism of dynamic change. Can help to indicate areas where deep study would be valuable, and hence act as both as guide and stimulator to future research. Transition matrix summarization all the essential parameters of dynamic change. The results of the analysis are readily adaptable to graphical presentation and hence easily understood by resource managers and decision makers. Disadvantages: they are only able to systems that exhibit the Markov property, which means that the future state of the system is dependent only on the current state and not on the sequence of the events that led to the current state. They can be computationally intensive, especially for large systems or systems with many possible states. They may not accurately capture the behavior of systems that exhibit complex dependencies or long-range correlations. They may not be able to capture the full complexity of real-world systems, which can have many interacting variables and non-linear relationships. Problem on Markov chain. The transition matrix P of a Markov chain is given by matrix 1 by 2, 1 by 2, 3 by 4, 1 by 4 with initial probability distribution. Define and find the following: P21 of 2, P12 of 2. The given P matrix is equals to 1 by 2, 1 by 2, 3 by 4 and 1 by 4. We have to find P square. P square is equals to P into P. We have to multiply P matrix into P matrix. P square is equals to 1 by 2, 1 by 2, 3 by 4, 1 by 4 into 1 by 2, 1 by 2, 3 by 4 into 1 by 4. P square is equals to 5 by 8, 3 by 8, 9 by 16, 7 by 16. P square is equals to 5 by 8, 3 by 8, 9 by 16, 7 by 16. We can write as P11 of 2, P12 of 2, P21 of 2, P22 of 2. We have to find P21 of 2. P21 of 2 is equals to 9 by 16. This is the answer for A sub question. For B sub question, P12 of 2. P12 of 2 is nothing but 3 by 8. P12 of 2 is equals to 3 by 8. This is the answer for B sub question.